Greetings, sea fans. Welcome to the official channel for Thalassus.com. My name is Chris, and today the question we're going to be asking is, can crab urine help make your next oyster dinner possible? To get the answer, we head down to the Mississippi coast for a science ride-along with researchers from the Dauphin Island Sea Lab. Mississippi shores are often referred to as the Gulf of Mexico's secret coast. Miles of sandy beaches, sport fishing, and an active gaming scene are just a few of the things that the secret coast has to offer. Here you can find picturesque views, a destination for classic cars, and a vibrant arts community. Coastal Mississippi is also known for seafood, especially shellfish. Mississippi's shrimp, crab, and oyster industries send an average of $300 million worth of seafood every year throughout the United States as it supports communities and economies along the coast. However, over the last 15 years, Mississippi's oyster industry, which once supplied more than 40% of the oysters in the U.S. pre-Katrina, has seen a steady decline to near zero. The decline can be attributed to multiple factors, including hurricanes and the Deepwater Horizon oil spill, but the most recent and costly factor has been river flooding. The Mississippi River has flooded multiple times since 2008. This has required more openings of a Louisiana flood control structure called the Bonnet-Carré Spillway. Located 33 river miles north of New Orleans, the spillway is a 1.5-mile-long concrete weir that was built in 1931 by the Army Corps of Engineers after the Great Mississippi Flood of 1927, the deadliest in U.S. history. Today, it's used in conjunction with the levee system to protect New Orleans and its inhabitants during flooding events. As the river rises, some or all of the spillway's 350 gates are opened to allow excess river water to flow into Lake Pontchartrain, where it finds its way into the Mississippi Sound and Gulf of Mexico. The spillway has only been opened 15 times since 1937, but 7 of these have been since 2008. This includes a historic double opening in 2019 that diverted 10 trillion gallons of river water away from New Orleans for a record-shattering 122 days. When this excess freshwater reaches the Mississippi Sound, salinity levels drop for an extended period of time, causing mass oyster mortality events. The destruction of Mississippi oyster reefs has had profound economic impact on the Mississippi coast. Foregone landings over multiple years reached the millions of dollars, and hundreds of jobs have been lost per year. This has left many people, many of whom were multi-generational oyster fishermen, wondering where to go next with their lives. Restoration efforts continue to be a priority for the state, but reefs have not rebounded despite the millions of dollars invested. In order to grow and thrive, oyster reefs need a yearly supply of new larvae through reproduction and a suitable substrate of oyster shell or other hard surface as a base for new larvae. Before 2019, it was inferred that reef restoration was hampered by having too little substrate upon which new larvae could settle. Between 2013 and 2014, nearly 190,000 cubic yards of substrate was spread over 1,400 acres in the Mississippi Sound. This deployment had promising early results, but the near total loss of the oyster biomass after the 2019 double spillway opening meant the problem was no longer insufficient substrate. It was now lack of new larvae, and the focus had to change to increasing live and new larval oysters on existing reef sites. Today we're going to ride along with researchers from the Dauphin Island Sea Lab to learn about their unique method to help oyster populations recover in the Mississippi Sound. Let's meet the team. All right, so hey everybody, we're here with Krista and Ben from Dauphin Island Sea Lab, and we're about to go out and do some oyster research, but I thought we'd kind of get a little bit of an idea of who we're talking with here. What attracted you guys to this field?
So I am a first-year PhD student at the University of South Alabama in the SME lab. So my background is in coastal ecology. So I've always loved being outside, being in the water, and I love oyster reefs because they're so complex. I really like that community structure. Gotcha. And I like working in a field where what I'm doing is scientifically relevant, but also has a direct impact on people. So the oyster fishery is really important in the Gulf states, so I like doing something that is fun for me, but benefits others as well.
Gotcha. Ben, how about you?
Yeah, so I'm a research scientist in the SME lab. I started here as a postdoc and kind of just moved up in the ranks. And the reason why I got into oyster research specifically is because I really enjoy being in the water, as Krista said, but oyster reefs provide so many ecosystem services that we rely upon. They filter our water, they provide habitat for other important fisheries like sea trout and blue crabs. And they also stabilize our shoreline, not to mention we eat them. And so it's a really good way to be able to go out into the field and do fun work, but also provide habitat and help sustain habitat that's really important not only for the economy, but also for the entire ecology of estuaries.
Well, let's talk a little bit about the project we're doing today. So everybody has seen oysters, or we've seen these places at restaurants. Some, like myself, can only eat them cooked, some like them raw. Give us an idea. We've all heard of an oyster. What exactly is it? Like, what's its life cycle? What is it, what's its habitat look like? How do they, what do their reefs look like?
So oysters are an estuarine species, so they live in these places where freshwater and saltwater meet.
Okay.
They may not look like much. So their reefs are not what you think of as like this beautiful coral reef with all of these colors. They kind of look like hunks of rocks on the bottom, at least in this part of the world.
Right.
But there's some really awesome secrets inside of those hunks of rocks. So just because they're not pretty doesn't mean they're not important.
Got it.
So oysters, once they settle, can never move. They can open and close to feed, but they're stuck where they go. So what they do as adults, they broadcast spawn. So they release their gametes into the water column as larvae, or little itty bitty babies.
Yeah.
They're fertilized externally. They drift about for about 2 weeks. And then they grow a little foot.
Okay.
And when they grow their little foot, they swim around as much as something that has tiny little cilia. I mean, when I say swim, it's right?
They put in enough effort.
They kind of look like drunk bees, is my best description. Tiny drunk bees.
Got it.
They swim around until they find something hard, and their preferred substrate, what they are looking for, is calcium carbonate. Basically what adult oyster shell is made out of. And that makes sense from an ecology perspective, from an evolutionary perspective. If an oyster grew up and survive to adulthood, that's a good place for an oyster to be.
Makes sense.
So they find a hard substrate, they settle down, and they start to grow. In the Gulf, within about a year, they'll be about market size. In colder areas, it takes a little bit longer.
Got it.
And those reefs just form these aggregates. And what's really important about that is we call them ecosystem engineers. So oysters change their physical environment in so profound a way that it actually allows this increase in diversity of other species.
Oh, wow.
They create habitat for other things.
Okay.
So here, you've got this nice muddy bottom. And it's not all that differentiated. It's just kind of mud everywhere.
Yeah.
So those oysters, as they attach to each other and grow, are providing this big three-dimensional structure with all these little crevices and cracks for little worms and tiny larval fish and crabs and all sorts of organisms to live in, be protected from being eaten. To eat.
Yes.
So they provide a different structure that provides all of this habitat in addition to some of those ecosystem services that Ben mentioned.
Awesome. So let's talk a little bit about this particular project. What are we going to be doing today, and how is this going to be affecting oysters for the Gulf of Mexico in the future?
Okay. So what we're working on right now involves predator cues and inducing a response. So the short and easy version is that oysters have natural predators, say like blue crabs. And if you expose young oysters to a high enough concentration of a predator cue, what we mean by that is usually what that blue crab is putting off, so urine. They can smell it. They can chemosense it, and they will build thicker shells because they're trying to protect themselves. If there's lots of predators around, oh no, that's scary, and they beef up their shells. And what that can mean is that you end up with an oyster that's stronger, that can resist being predated at a much smaller size because it has this thicker shell. And predation on very young oysters is extremely high. So oysters make millions of babies all at once because most of them won't make it. So even just a tiny change, say a 1%, 2%, 10% improvement in their survival at a very young age can have massive impacts. So what we're doing today is going to pick up some 3-month-old oysters that were induced with predator cues, so raised in tanks with blue crabs. They get that scary smell. And they buff up their shells, and we put them out on restoration reefs with the Mississippi Department of Marine Resources. So they're actively trying to restore reefs in these areas.
Awesome.
And the hope is that because we are inducing these oysters, because they have these thicker shells, they're going to survive better within that first year of their life.
Ben, anything else you want to add?
Yeah, so right now this is a pilot project to show proof of concept that it is good to add these cues in the hatchery system to substantially increase the number of oysters that make it to adulthood. And so we don't know how many will make it to adulthood or if it's economical for us to start adding the chemical cues in the hatchery.
Got it.
So this is informing the Mississippi Department of Marine Resources that yes, this is worthwhile to do, and you will have better, more efficient operation if you do that.
Awesome. So it is literally a field test.
Yes, literally.
Okay. Well, this sounds exciting. I know that there's been some challenges for oyster reefs in the Gulf of Mexico, and this
Very
could
much
really
so.
go a long way to maybe helping those bounce back and see some resilience.
Yeah.
Yeah.
Okay.
I hope.
All right. Well, let's go watch you work.
Okay.
Science, folks. It's not always clean.
Never clean.
Yeah, it's not always dry.
So after a quick ride out into the Mississippi Sound, it was time for Ben to dive down into the water to pick up the oyster crates and cages.
Ben and/or I are gonna hop in. That buoy is connected to a piece of PVC, like one of those that's rebarred to the bottom, and along it we have little baby milk crates. Each of those milk crates has a sample of oyster shell that has been set by Department of Marine Resources with babies. So they're about 3 months old. The different colors relate to different tanks, so they have some different treatments. So you'll see a bunch of different colors come up, but you're also going to see some have cages and some do not. The cages are a control for predation. So if we were to see that, hey, we have a lot of oysters left, we can't actually say they died or didn't die because they did or did not get eaten by predators. So by putting a cage on them, essentially we're controlling for, did the predators do this or did something else do it?
To give you an idea, this is what's on the bottom, right?
Wow.
So not nice and pristine and clean.
Definitely not.
So these are from the Auburn spat. Okay, so these guys are about 3 months old. So you can see each one of these is a live oyster and 3-month babies.
Okay.
It's important to remember when they set, so when we first have spat, they're so small you can barely see them.
Got it.
They look like a little pinprick. So these guys are growing really well. So these are from Auburn. I can tell by the color.
Okay, so you said that each lab's got its own colored cage.
So there's different colors for both the 2 different sources of larvae.
Okay.
And then also whether they were raised in a tank with crabs, so induced, or not with crabs, uninduced.
Got it.
So this was raised with crabs.
Okay.
And we can see we've made it quite the habitat, even with only 3 months of being out here. So we've got
Oh yeah,
like a
little
little blenny. So the caged ones look like,
Oh wow.
we call it a predator exclusion. It's more of a predator deterrent.
Got it.
So some things obviously can fit through those holes. So
Sure.
very, very small crabs and things. But these oysters are big enough at this point that those little crabs aren't eating those oysters.
Makes sense, yeah.
Unless they're already open.
Little oyster fort.
Yes. But I do want to go ahead. Aha! We do have some babes. Come here, bud. Please don't pinch me. You're pointy. Maybe I'm gonna get him, maybe I'm not. Oh no, he got me!
Oh wow.
My little crab.
Yeah.
So these guys are absolutely eating small oysters.
Ruining everything.
Yeah. Oh, I mean, that's it's making an ecosystem, right?
Yeah,
so
it's
like,
part of it.
the point is not to keep anything from eating them. It's to let enough of them live longer that it's helpful. I think that's most of the stuff that's gonna crawl out on its own.
Okay.
Well, the stuff is a little stay at the bottom.
All right, so the things that you're seeing on these are going to be documented.
Yeah, so basically I keep track of what's in each cage so that later Jess can help me identify down to species or at least group.
Okay.
And so I know what's eating them and what's hanging out in the area. So some of the research that other lab members are doing in Alabama, the major predator are oyster drills, which is a predatory snail that can actually scrape holes in the shell and suck the oyster out.
Wow.
Here, I really don't see oyster drills. I see crabs. Lots of crabs.
Mm-hmm.
So pulling these up is easier than putting them in.
I can imagine.
So looking at these, we are working in water that's 7 feet deep.
Yeah.
Which is just deep enough to be annoying.
Yep.
And we have these cages, and they have oyster shell in them, so they're heavy. And we need to make sure they don't move when things like a storm roll through. So we have to rebar them down into the substrate. And
Makes
remember,
sense.
there is shell laid out over this whole area as culture plant with all this oyster. So our cages are just samples of a much larger amount of shell that's put out here to the reef.
Got it.
So we're diving down to the bottom in water we absolutely cannot see through.
Yeah.
Visibility is about here, if that good.
I was gonna say.
It's mostly just like trying to swim in chocolate milk. Doesn't taste as good. And we have to dive down to the bottom, push rebar through them, and you have to try to keep them together so you can find them later and not dump any shell out of those cages while that's in the tank.
Wow.
So it's a new skill set.
So now that all the oyster crates and cages have been collected and the animals in them documented, it was time to head back to the dock.
We have made it back to the dock. We are now somewhat dry.
Yeah.
The samples have been collected, they've been recorded, they've been stuck back in the truck, and they're on the way back to the lab. So what are going to be the next steps for this project? What do you do when you get back to the lab?
So the next steps are clean the boat.
Yeah, of course.
But for the samples themselves, they're going to go back to the lab. We will count the number of live oysters on every single one of those shells. So essentially we do that over time to tell us survival. So if we get a count at 1 month, at 3 months, at 6 months, we know how many of what we put out is actually staying alive, which is really important. We want to know that what we put out there actually is alive a year from now.
Yeah.
And you got to check to know that.
Yep.
We're also going to measure their shell length, which is just how big they are. And we use a force probe and crush them, which sounds a little mean. I promise I don't crush that many.
Yeah.
But we do that to see how strong their shell is.
Okay.
So
that's the factor that kind of tells you whether or not that shell is thickening up.
Exactly. So
Okay.
we know when they went out that these babies had induced. So the ones raised in tanks with crabs built up those big buff shells. But we don't know how long they hold on to those big buff shells. They may decide, no, there's no crabs anymore. We can start weakening them up a little bit, put that energy somewhere else, and
Got
just
it.
say reproducing. Or growing bigger instead of stronger, because those are different things. So we crush to see how strong those shells still are, so we understand more about how long they have that induced effect.
Okay. But yeah, Krista, thank you so much.
Thank you.
We really appreciate your time.
Yeah, I appreciate it.
So a few months after our trip, I got a chance to check back in with Krista about the results of the field test, and the outlook is really encouraging. Oysters that were raised with crabs had 80% stronger shells and a 60% higher survivability rate in the field after 1 month. This indicates that this method is indeed usable at hatchery scale. Now, there's still a lot of work that needs to be done, but this is promising news that may help give oysters in the Mississippi Sound a fighting chance at recovery. Well, that about wraps this one up. We'd like to offer a huge thank you to the Dauphin Island Sea Lab, to Drs. Lee Smee, Ben Belgrad, Jessica Lunt, and PhD student Krista Russell for allowing us to ride along with them on their workday and for giving us the opportunity to share this awesome work they're doing. If you enjoyed this, please consider liking the video or subscribing to the channel so we can help share more of the hard work that marine biologists are doing every single day. And don't forget to check us out at thalasis.com. Thanks so much. See you next time.